Hello everyone, I am Imyam. On this video, I will present my AI programming project on phishing URL detection using machine learning, deep learning, and assembly method. Phishing websites are major cybersecurity threat where attackers create fake sites to steal sensitive information like passport, financial data. This phishing URL chain frequently make them hard to detect. Traditional rule-based systems often fail to catch new attacks. Therefore, AI-based approach are important as they can learn the pattern from the last dataset and improve phishing detection accuracy. This dataset used in this project contains 200,000 URL. It includes 50% of phishing URL and 50% of legitimate URL. From this URL, 89 features were extracted. This feature include URL structure, characteristics such as length, number of dot, hyphens, domain information, and traffic or security indicator that have to identifying URL pattern. This is the sample or dataset. In addition to main dataset, top 1 million trusted domain dataset were used for domain reputation checking. This dataset contains popular legitimate websites. It have to reduce false positive by identifying trust domain that should not be classified as efficient. This is the component and purpose. First, DFIDF vectorization converts URL into numerical vectors using a character gems allow model to capture phishing pattern in URL structure. Since this produces a very high dimensional feature space, SPT is applying to reduce the number of features and improve computational efficiency. Next, logistic regressions such as the baseline linear model that estimate the probability of a URL being phishing. SPN is particular effort for the high dimension data and find the optimum boundary between phishing and legitimate URL. Random forest and tree-based ensemble model capture nonlinear relationship and improve robustness by combining multiple decision trees. And DLL is used to learn complex features, interacting feature, further improving detection performance. By LSTM is used as a deep learning model that processes URL character sequence in both forward and backward direction. This allows the model to capture more contextual and then sequential phishing pattern that may not be detected by traditional model. GRU is another sequence-based model that works similar to LSTM, but it is more computational efficient with fewer parameters. It has learned important character pattern while reducing training time. To improve overall performance, an assembly model is applied. It combines prediction from the multiple model using average probability with increased reliability and reduce individual model errors. Threshold tuning is used to adjust the decision boundary between phishing and then legitimate URL, variant detection, accuracy, and then fault alignment. Finally, error analysis is performed to examine misclassified URL, have identified model weakness, and then improve future performance. This diagram shows the phishing detection process is begin with input URL. Pre-processing features are extracted using the FIDF or secret method. Then machine learning and deep learning model are applied. The results are combined using an assembly approach. The model is evaluated using accuracy, ROC, AUC, and error analysis, followed by a trusted domain check to produce the final phishing and legitimate classifications. The dataset was split into the training 160,000 and testing 40,000, set using certifying simply, ensuring balance phishing and legitimate URLs for the reliable evaluations. This slide compares the performance of different machine learning and deep learning models. The results show that all models achieve high accuracy, detecting phishing URL, demonstrating that both traditional machine learning model and deep learning approach are effective for this task. For assembly model, a URL is analyzed by the multiple model, machine learning, and deep learning model. Their output are combined using average probability, putting to improve reliability. The system achieved high performance with about 99 accuracy and strong precision and then recall. The graph shows the ROC curve for all models. The ROC curve measures the trade-off between true positive rate and false positive rate. The AUC value for all models are close to 1, indicate strong classification performance and then effective detection of the efficient URL. The slide shows threshold tuning for the assembly model. The best threshold is selected to balance prediction, recall, and advanced score for the optimum performance. This slide shows the error analysis, including for positive and for negative, to have identified model winner and then improve performance. Next, I will show how phishing URL detection system work in practice. So as URL is analyzing using multiple machine learning and deep learning model, the final result is generated using assembly approach. In this example, the URL is classified as a phishing is very high probability of 99.98% indicate high risk. The system show individual model prediction explanation have to understand final decisions. Let me show for our university website. So our university website is for sure legitimate. So you maybe see that although the Y is become legitimate, then the model prescription summary, and then all explanations. So in this project, show that artificial intelligence can effectively detect phishing URL by combining machine learning and deep learning model in an assemble approved that system achieve high accuracy and reliability. Overall, demonstrate how AI can enhance cybersecurity and help protect user from the phishing attack. Thanks for listening.